Hey, let's talk about 7.3. This is our last assignment for the year. Let's talk about factoring polynomials. Okay, so there's different strategies. There's different strategies for factoring. You can always, if you can take out a greatest common factor, do that. Unless you have one of these situations at the bottom where you can already use one of these tricks to factor. Factor out your greatest common factor first. So that's like, here's an example. If I've got like 6x cubed plus 3x squared plus 9x equals 0. I can factor. All of these can all be divided by 3, and all of these can also be divided by x to the 1, right? So if I take a 3x out of each one of these terms, I take a 3x out of 6x cubed, that gives me 2x squared. I take a 3x out of 3x squared, that leaves me with a 1x. And I take 3x out of 9x, that leaves me with 3. So that's factoring out the greatest common factor. Sometimes you can only factor out a number. Sometimes you can only factor out a variable. Sometimes you can factor out both. Whatever helps make your life easier when doing factoring, do it. So these are the different little tricks. So we just talked about factoring out the greatest common factor. Difference of squares, that's if you have, if you've got two perfect squares, one subtracting from the other. So if I've got 4x squared minus 9, well, 4x squared is a perfect square because 2x times 2x gives me 4x squared, and 9 is a perfect square because 3 times 3 gives me 9. So when I'm doing a difference of squares, when I recognize that I have a difference of squares, it factors into a plus b and a minus b. It's just your what your perfect squares break down into. So this gets factored into 2x plus 3 and 2x minus 3. That's what this breaks down into. That's a perfect square. That's the difference of squares. Then there is perfect square trinomials. That was, I don't know if you remember, we did that when we talked about completing the square. So you can complete the square. If it's in this form, it factors to a plus b squared. If it's in this form, it factors to a minus b squared. Then we have the sum of two cubes. It factors into a plus b, and then a squared minus ab plus b squared. Difference of two cubes. So it's just about recognizing the different patterns in what you're factoring. So remember, perfect squares are like 4, 9, 16, 25. Those are perfect squares, right? Perfect cubes is 2 times 2 times 2. So 8 is a perfect cube. 3 times 3 times 3, 27 is a perfect cube, so on. So instead of perfect square, which, 2 times 2 is 4, 3 times 3 is 9, perfect cubes, 2 times 2 times 2, 3 times 3 times 3. So 27 is a perfect cube, 8 is a perfect cube. It just takes a little recognizing. If I were trying to figure it out, I would just take a calculator and do try to figure out cube root of each one, So here's some examples. It's just about recognizing what you've got, right? It's just about recognizing what you've got. So here, our first example, there's this guy. It looks like we can factor out an x from each one of these. We can't factor out a number, right? Because there's a 1, a 3, and a negative 10. Those don't have any factors in common, but I have an x cubed, an x squared, and an x. I can factor an x out of each of these terms, and that leaves me with x squared plus 3x minus 10. So I've got the x hangs along for the ride, right? And then when I just factor these, you know, what are factors of -10 that when added together give me a +3? Well, +5 and -2. So here I've factored it. Let's take a look at our next example. It involves two different things, right? It involves factoring out my greatest common factor and then recognizing that I have a difference of 2 cubes. So first I take a look at this. I can't factor a variable out of either one of those, right? Because I've got an x cubed and then no variable here. By the way, kind of a dead giveaway that you're gonna have the sum or difference of 2 cubes if one of your variables is cubed. So keep an eye out for that. I know right off the bat that I can factor out a 10. I know I have a greatest common factor of 10 of both of these guys. I take a 10 out of 10x cubed, that leaves me with x cubed. When I take a 10 out of 2,160, it leaves me with 216. This is a difference of 2 cubes, right? Number 5. So, and here's my instruction right here. I know exactly how it maps out. So I've got my difference of 2 cubes here factors into the base of A, the base of B, right? And it's in this form. So my A, first identify your A and your B. It'll make life a lot easier. So 6 times 6 times 6 gives me 216. So my B is 6. And x times x times x gives me x cubed. So that's my A. So now I can just plug those into my guide right here. So A minus B, well, that's x minus 6. And then a squared, so x squared, plus a times b, so that's 6x, plus b squared, which is 36. And this 10 still needs to come along for the ride, right? So my final answer is this guy. This guy. So the 10 stays along and just hangs out on the outside. So since I factored that out, it stays with my answer in the end. And then I just follow the instructions on how to write my factored answer here. So when I recognized it was difference of cubes, I knew I was going to be using this. So I was able to identify my A and my B, and then just the homework's super short. You know, the idea for all of these wasn't to do like a super intricate dive into all of these subjects. It was just to kind of touch on them, give you a basic idea of what Algebra 2 is going to be like next year. If you have any questions, please let me know. Bye, guys.